Good morning, everybody. We are about to get started with our third week of at-home learning with 6.3, talking about parallelograms. Okay, so without further ado, let's get this party started. It's a little bit blurry, I know it says here, but we're going to start off with a couple of theorems. So the first one, it says if a quadrilateral is a parallelogram, then its opposite sides are congruent. Now, if you remember, when we mark something as congruent, we need to use little dash marks. So these opposite sides right here are congruent. These opposite sides right here, we'll use 2. Those are also congruent. All right, so that's our first thing that we're going to make sure we pay attention to. Now, remember, this right here, that means parallel, okay? The symbol that you're seeing on the right side, that's parallel. So it's telling us that these sides are parallel, but we know that they're also congruent, okay? So that's a big key. Now, our first example then is going to ask us to figure out what the missing side YZ is. So YZ is right here, and we know that that is going to be congruent to the side across from it. So pardon the mouse handwriting, but that is 3.27. All right, so that's all we have to do for that. That's our answer right here. Okay, done and done. Moving down to this next example, now it gets a little bit trickier. Okay, I'm going to try and maybe start typing this one out. So it wants to know, what is the value of x? What is the value of x for number 2? Well, to start off with, first of all, we know those sides are equal, or congruent, I'm sorry, and these are also congruent. So we're going to have to make an equation. Now, I would say, let's set up an equation between these two sides just because there's a little bit less there. There's just a 4x. It's a little bit less complicated. So let's do 4x equals 5x minus 3. Okay, so we want to get all the x's on one side, right? So since we have an x over here and an x over here, we want to subtract. Let's subtract 5x from both sides. Okay, that way, once we do that, we have a new equation. These will cancel out, which leaves us with, negative x equals negative 3. Okay, that's really a negative 1x, right? Oh, shoot. A negative 1x. 4x minus 5x is a negative 1x. We still have a negative 3. So now what we need to do here is divide both sides by a negative 1. Whoops. Sorry about the messy computer here. Divide both sides by negative 1, and we are left with x equals 3 being our final answer. All right. So, as you can guess, it's going to ask, what is the length of all those sides for part B? Find each length. So what does that mean we're going to have to do? We have to go and plug that 3 in place here, in there, and there also. So 4 times 3 gives us 12. Now let's plug in here. 5 times 3 is 15, minus 3, which leaves us with also 12, which is what's supposed to happen because the sides that are across from each other are supposed to be congruent. So that's 12. I should not use, that's 12 here, and that side's 12. Now that doesn't mean that these are going to be 12 though. So now we have to go through, find one of those sides. So let's do this one down here. 2 times 3 plus 12. So what's 2 times 3? That's 6 plus 12 is going to leave us with 18. And if this is 18, then up here, that is 18. And I'll use a different color. I'll use this one, yellow, for that. So what is the length of each side? PQ, that's 12. QR, that's on top, that's 18. RS is on the right side, that's 12. And PS at the bottom is 18. Now let's make that look a little bit nicer. And that's how we figure out all of those. All right, let's move along here. So this one's a little bit tricky. We've got a little bit of reading to do. The 600-meter fence around City Park forms a parallelogram. The fence along Chaco Road is twice as long as the fence along Grover Lane. So what is the length of the fence on Jones Road? Okay, so here's a couple of key pieces of information. The first thing is there's 600 meters for the entire fence, okay? The whole thing, all the way around, is 600. Well, it says also that this fence right here on Chaco Road is twice as long as this part. So do we know how long Grover Lane is? No. So we're going to call that side X. And if this side's twice as long, we're going to call that 2X. Okay, so if this side is X here, what would this side be? That side would also be X. And this side down here would be 2X because the sides across from each other are equal. So we're going to make an equation that 2X plus X plus 2X plus X, all four sides, 2X, X, 2X, and X, all of those together equals 600. Okay, why is it 600? Because that's what they said earlier at the beginning. Oops. They said at the beginning it's a 600-meter fence, so it's a 600 total length. So combine all of our like terms, 2X, 1X, 2X, 1X. That is going to get us to 6X equals 600. And if we divide both sides here by 6, we end up with X equals 100. So that means then if we have X equals 100, then let's find let's use red here. Then this is 100, this is 100, and then these sides here, 2 times X, that's 2 times 100, which is 200, and 200. Okay, so let's see. What was the question? What is the length of the fence along Jones Road? Jones is over here. So our final answer is 100 meters. I know it's kind of sloppy. Wish I had a smart board or something like that at home. That'd be cool. Okay, so that's how we do that part. Let's go ahead and let's move down here. A couple more theorems. All right, we're going to fill in some information. It says if a quadrilateral is a parallelogram, so it's saying this is a parallelogram, then consecutive angles, remember consecutive means next to, okay? That means next to. Our supplementary, it's kind of cut off, but remember supplementary means they add to 180. Okay? We're going to fill something in here in a minute. But the other part that it says here is that in a parallelogram, opposite angles are congruent. Opposite angles are congruent. So, a couple things. What I like to do, I like to kind of show this in one way. There's one way that we can kind of show this all at one time. Right next to angle A, I'm going to put an X, okay? And in this, if this angle is X, then the one across from it should also be X because of what this theorem says. Angles across from each other are congruent. Well, are these two that are right next to each other congruent? No. So I'm going to put a Y there. Come on. Which also means that the angle across from the Y is also Y. Okay? So I'm going to take those, copy and paste those all the way down here because we have the same thing going on. But we are going to know that X plus Y, whatever those two measures are, this X and this Y, they're going to add up to 180. Okay? So no matter what the measurement is for each of those angles, the angles across from each other are equal, but the angles that are next to each other, no matter which X and Y you pick, will add up to 180. That's what they say here, supplementary. All right, so let's put that to the test in this example. Given that we have a parallelogram, what are the measures of angle A and angle C? All right, that's part A. So angle A is right here. It's next to 114 degrees. So here's what we're going to do. We're going to do 180, and we're going to subtract 114 because this angle A is right next to the 114. They should add up to 180. That number comes out to 66, which means that angle A is 66, and that means angle C is also 66 because they're across from each other. Okay, so they're both 66 degrees for part A. So what is the measure of angle B then? Well, if angle D here is 114, then angle B across from it should also be 114 because angles across from each other are congruent. Okay, so I hope this doesn't make it too messy, but I'm going to kind of make a little arrow mark in here. Those two are equal, and those two are equal. So across the little arrow that I wrote are always going to be equal to each other. Okay, let me see. I think, yeah, this is the last. No, I'm sorry. We got two more. Okay, so inside of here, it says the green shape is a parallelogram. The measure of angle 2 is twice the measure of angle 1. So what are the measures of angle 1, angle 2, and angle 3? So this is a very similar problem to what we did before. It says angle 2 is 2 times, it's twice the measure of angle 1. So I'm going to do 2x here and an x here. And then just like before, if we see they're right next to each other, these angles are right next to each other, that means they add up to 180. They're not equal if they're next to each other. They could be, but not always. Okay, that's only if you had a square or a rectangle, and we'll get to that later. But these two are right next to each other. I'm going to add in this angle and this angle are supplementary. All right, so back to the problem at hand. Whoops. So 2x plus x, they're going to add up to 180, which means that we're going to have 3x equals 180. And when we divide both sides by 3, we're going to get x equals 60 after we divide both sides here. So x is 60, so that means that this angle right here is 60 degrees. And then this angle up here is 2 times that, which is 120 degrees. So how many degrees would angle 3 be? Well, that would also be 120 because it's across from angle 2. So measure of angle 1 equals 60. The measure of angle 2 equals 120. And the measure of angle 3 equals 120. That's our final answer. Okay. So, very similar problem here, just a little bit more complicated. So, once again, though, the angles that they're giving us, the angles that they're outlining are H and G. And those two are next to each other, so they are supplementary. They're not equal. So, we're going to have to do A plus 5 plus 8a minus 5 equals 180. Okay, those two angles add up to 180. There's a plus 5, there's 8a minus 5. We add them together. Now we got to combine our like terms. Okay, so let's see who misses their algebra. 1a plus 8a is 9a. And then how about this? Plus 5 and a minus 5, positive 5 and a negative 5, that's nothing. They cancel out. So they're gone. We just have 180 degrees. So we need to just divide both sides by 9, and we get a equals 20. So A equals 20 is the answer for part A. Now it wants to know what are the measures for angle G, angle H, angle J, and angle K. So in the measure of angle G, we're going to take 20 and plug it in right here. I'm going to go ahead and take this A equals 20 and plug it in for A. We're also going to have to do that right there. So this one, 8 times 20 minus 5. So 8 times 20 first is 160 minus 5 equals 155. So that's this one, 155, which means across from it, that's really ugly. I'm going to kind of get rid of that. So 155 is going to go to angle G, and it's also going to go to angle J. So how about this one then? Angle H, A, which is 20, plus 5, well, that's 25. So that's what H is, and that's also what K equals. So I know that gets really sloppy, and when we save these, I'm going to kind of find a way to erase that, I think, because that doesn't look very good. But here, angle G is 155. The measure of angle H equals, let's see, that's right here, so that's 25. Let's go over here. The measure of angle J, that's this one. That was in green, 155. And then the last thing is the measure of angle K, which is here, which is in blue, and that's 25. Okay, so I'm going to try to get rid of a couple of those things. Whoops, I guess I shouldn't do that. Hopefully it's not as messy. Okay, so this right here, though, that is all our final answers for example number 4. All right, so just a couple of things to finish off with. I know this has been kind of a long video. In a parallelogram, the diagonals bisect each other. So that means this part and this part of this diagonal are equal. This part and this part of the diagonal are also equal. So going down to a couple of these questions, SU, this whole thing, SU is outlined in red, is 35. So what is SK? Well, what we need to do, if this whole thing is 35, we know that both parts of it are equal. So what we're going to have to do is do 35 divided by 2, and that's going to give us 17.5 for part A. Okay, now the second part, it wants to know what RT equals. Well, let's say KT is 19. KT right here is 19. So RT goes all the way across. So RT then is, we're going to take this 19 and we're going to have to double it. So 19 times 2, which is going to be 38 to get our final answer. Okay, so if they give you just one part, you need to double it to find the whole thing. If they give you the whole thing, you need to divide it by 2 to find each part. All right, so the very last example they have here is PK is equal to 4. Okay, so PK is right here. That they give us that is 4. And HK is 2/3 of GJ. That's tough. So what is GP? Well, first of all, if this is 4, then this is 4 also. Okay, because they're both the same. So it says HK, which if you look at it, HK goes all the way across, so that's 8, is equal to 2/3 of GJ. So this is where it's a little bit tricky. What you're going to have to do, you can do this really in 2 parts. You can multiply both sides by 3, because what that'll do is cancel this thing out. That gives us 24 is equal to 2 times GJ, and then divide both sides by 2. So we get 12 is the length of GJ. My goodness, that is sloppy. So that's this whole thing. This whole thing is 12. So what is GP? GP is half of that. So do 12 divided by 2, and that will equal 6. All right, that's a very tricky problem. It's a really tough one. That's why they put it at the very end. But that's something that we could do if we just go step by step. Okay, just a couple things at the very end of this is you'll see there's a couple of the checklist. All the characteristics of a parallelogram have an X next to them, and then the stuff that we talked about are outlined here. Okay, opposite sides are equal, opposite angles have the same markings, and opposite sides are also parallel. And as we scroll down here, what we just talked about, diagonals, the left side and the right side are equal. Left side and the right side of that one are equal. All right. So that's it for today, this week's lesson. If you have any questions, once again, please feel free to let me know. All right. And I hope you guys have a great week.